Shri Gurubhyo Namaha. Welcome to our online learning initiative Ekalaiva. Let us discuss expression for Fringe with in Young's double slit experiment. Let us consider a narrow slit S is illuminated by monochromatic light of wavelength lambda, and S1 and S2 are two narrow slits at equal distances from S, and the slits S1 and S2 act as two coherent sources, and they are separated by a small distance d. That is, the distance between S1 and S2 is small d, and the interference fringes are obtained on the screen, which is placed at a distance of d from the sources S1 and S2. So small d be the distance between S1 and S2, and capital D be the distance between the coherent source and the screen. Now let us consider a point P on the screen, which is at a distance of x from the center. The nature of the interference at the point P, which depends on the path difference. So now let us find the path difference. The path difference P is equal to S2P minus S1P. Here we are going to consider two right angles, S2BP, S2BP and S1AP. So let us consider the right angle triangle S2BP and S1BP. What is S2P square minus S1P square? So S2P square, which is nothing but S2B square plus PB square minus S1P square here. So S1P square is S1A square plus PA square. So what is this S2B? S2B is nothing but capital T. So from the diagram itself you can write B square plus PB square. So look at the diagram, PB square. P to O is X, and again from O to B is D by 2. So can we write it as X plus D by 2 the whole square. Similarly, S1A, which is again D. So D square plus what is PA? Again from O to P is X, but O to A is D by 2. So this will be written as X minus D by 2 the whole square. So now let us write this S2P square minus S1P square as A square minus B square, which can be written as S2P minus S1P into S2P plus S1P. Okay. So this will be written as, we have to expand this term, children. So when you expand this term, what will you get? B square plus x square plus d by 2 the whole square plus 2x d by 2. Then what do you have? Minus d square plus x square plus again d by 2 the whole square minus 2x d by 2. So you can cancel this 2 to everything here. So again S2p minus S1p into S2p plus S1p is equal to, so you just bring this negative sign inside the bracket, then you can see that this d square will get cancelled, and similarly x square will get cancelled, and this term will also get cancelled, but you will have xd plus xd. Okay, because here you have xd minus xd, you will get plus xd, so this will be equal to 2xg. Okay, so S2p minus S1p. Actually, this is our path difference, right? So 2xd divided by S2p plus S1p. Actually, in practice, this point P, which lies very close to O. So therefore, we can consider, so this consideration is very important here, children. The point P is the point P is very close to O. Therefore, you can write it as, that is S2P is equal to S1P is equal to capital D. So when you substitute it here, what will you get then? So you will write it as 2xd divided by D plus D. So you will get 2xd divided by 2d. Okay, so this is your path difference. So this 2 and 2 get cancelled. So the path difference will become xd divided by d. Okay, so this is your path difference. That is, what is this? S2p minus S1p. S2p minus S2p minus S1p is equal to the path difference p. Okay. Now, let us find the positions of bright fringes and dark fringes. So, we got what is the path difference. Path difference expression is xd divided by d. What is the small d? Small d is nothing but the distance between the two coherent sources. And capital D be the distance between the coherent source and the screen. Okay, so keep it in mind. This is very, very important when you do the problems, children. So first, let me write the path difference here. Path difference P is equal to xd by d. This is very important. So positions of bright fringes. Positions of bright fringes. So that is for constructive interference. Or constructive interference. Already we know the condition for constructive interference n lambda. Okay. So here xd by d is equal to n lambda, or else x is equal to n, x is equal to n into d lambda divided by small d, where n is equal to 0, 1, 2, 3, etc. Okay. So till the nth fringe you can find this. Okay. So n into d lambda divided by d. This is for, actually I can write here xn. This is for nth fringe. N d lambda divided by d. Okay. This is for nth bright fringe. Nth bright fringe. Similarly, we can find the positions of dark fringes also. So, positions of dark fringes. That is for destructive interference. So, this is for destructive interference. Again, we know the relation. So, xd by d be the path difference, and the condition for destructive interference is 2n minus 1 lambda by 2. So, what is this x? X will become 2n minus 1 d lambda divided by 2d. Okay, so this is for destructive interference or for dark fringe. Okay, so here for bright fringe it is n into d lambda by d, but here it is 2n minus 1 d lambda divided by 2d, and again where n is equal to 1, 2, 3, etc. Okay. For the nth dark fringe, how can you write? For the nth dark fringe, it is 2n minus 1 d lambda divided by 2d. This is for nth dark fringe. Okay. And here, one thing we have to note here, the central point O is equidistant from S1 and S2. So, the path difference P is 0. So, there will be a bright fringe at the center. But as we move from O either upwards or downwards, we will get alternate dark and bright fringes. Okay. So, now let us see what is the fringe width. Fringe width. So, fringe width. Which is nothing but the separation between two successive bright or dark fringe. So, how will you find that? You can either for constructive interference or for destructive interference you can find. Okay. So, let us find this fringe width beta for constructive interference. So, beta is equal to, so which is nothing but xn minus 1. So, again you can substitute it as n d lambda divided by d minus n minus 1 d lambda divided by d. So what will you get now? D lambda divided by d. So this is nothing but fringe width. So beta is equal to beta be the fringe width. Beta is equal to d lambda divided by d. So again this is the most important formula. Okay. So what is this fringe width, children? It is the separation between two successive bright or dark fringes, and this is the path difference. Okay, so path difference. Path difference formula is xd by d, and for nth bright fringe it is xn is equal to n d lambda divided by d. Lambda be the wavelength of the light, and the capital D be the distance between the coherent sources and screen. Small d be the distance between two coherent sources, and beta is equal to d lambda divided by d, which is the fringe width. To receive our online lessons, please press the subscribe button and you will receive the latest updates. Thank you, students.